This question is to solve a 3x3 determinant equation where the determinant is set to 0. Please subscribe to our YouTube channel Math Tutor 8285. Your subscription fuels the passion. Let's grow together. Thank you so much. Question. Given a 3x3 determinant with entries as follows. In the first row, lambda minus 2, 1, and 1. In the second row, 2, lambda minus 3, and negative 2. In the third row, negative 1, 2, and lambda plus 1. The determinant is equal to 0. Which of the following four choices gives the correct set of real solutions for lambda? First, we start by understanding the structure. We are asked to find the values of lambda that make a 3x3 determinant equal to 0. This means we need to simplify the determinant until it becomes a cubic equation, and then solve it. So we look for a smart simplification, ideally, a row operation that creates zeros and makes the expansion easier. Next step is to row operation to simplify. We decide to perform a row operation. We add the first row to the third row. This gives us a new third row where the first element becomes lambda minus 3, the second becomes 3, and the third becomes lambda plus 2. Now we subtract the original first row from this new third row. After this subtraction, the updated third row becomes 0, 2, and lambda plus 1. So the determinant now has a 0 in the third row, first column, which makes expansion along the first column much easier. Then, next step, expanding the determinant. We now expand the determinant along the first column. The first element is lambda minus 2, and its cofactor is the determinant formed from the second and third rows and the second and third columns. That 2x2 determinant contains first row, lambda minus 3 and negative 2, second row, 2, and lambda plus 1. We then subtract 2 times another 2x2 determinant, which comes from the first and second rows and the second and third columns. This second determinant contains first row, 1 and 1, second row, 2, and lambda plus 1. We now compute both of these smaller 2x2 determinants in the next step. After that, next step, computing the 2x2 determinants. First, the cofactor for lambda minus 2. Multiply lambda minus 3 by lambda plus 1, which gives lambda squared minus 2 lambda minus 3. Then subtract negative 2 times 2, which adds 4. So the first determinant evaluates to lambda squared minus 2 lambda plus 1. Next, for the second determinant, multiply 1 by lambda plus 1, which gives lambda plus 1. Then subtract 1 times 2, which gives 2. So the second determinant becomes lambda minus 1. Putting it all together, the full expression becomes open parenthesis lambda minus 2 close parenthesis times open parenthesis lambda minus 1 squared close parenthesis minus 2 times open parenthesis lambda minus 1 close parenthesis. Next step is to factor and simplify. We first recognize that lambda minus 1 squared is a perfect square. Now, factor lambda minus 1 from the whole expression. We are left with lambda minus 1 times open parenthesis lambda minus 2 times lambda minus 1 minus 2 close parenthesis. Now multiply lambda minus 2 and lambda minus 1, which gives lambda squared minus 3 lambda plus 2. Then subtract 2, giving lambda squared minus 3 lambda. So the final factored expression becomes lambda times lambda minus 1 times lambda minus 3. Next step, solving the equation. We now solve for when this product equals 0. Set lambda times lambda minus 1 times lambda minus 3 equal to 0. That means lambda could be 0, or 1, or 3. So the correct answer is option A, lambda equals 0, 1, and 3. When you see a determinant involving variables, look for smart row or column operations that create zeros. This makes expansion far easier and often leads directly to a factorable equation. That's it for this question solving. This video is based on our math tutoring blog and class recordings. Hope you enjoyed it. Please subscribe to our channel Math Tutor 8285 and turn on the notification bell. Press the like button. Your subscription fuels the passion. Let's grow together. Thank you so much.